In this section, we are going to look at problems with friction. There are two types of frictions: static friction and kinetic friction. Static friction force applies when an object is stationary, while the kinetic friction applies for moving objects. So in this graph shows a friction force, y-axis, versus the applied force. Initially, when you increase the applied force, the friction force increases as well. So that means there is no motion here. So in this part, the object is at rest because the applied force is equal to the friction force. But when you increase it further, then the object starts moving. So in that point, we can see kinetic friction is acting against the motion. This value is the maximum value of the static friction. We label it as Fs max. You can also see there is a small drop in the friction force when the object starts moving. So these are the equations. For static friction, the static friction force is always less than or equal to mu s times Fn. Mu s is called the coefficient of static friction. Fn is the normal force. Fs max, the maximum static friction force, is equal to mu s times Fn. For kinetic friction, we use subscript k. Fk equals mu k times Fn. Mu k is called the coefficient of kinetic friction, and Fn is the normal force. So these are some examples. Find the friction force in the following. So we have a 3 kilogram block and the applied force is 2 newtons. There is no acceleration. So first we start with the free body diagram. So we have normal force, weight, then the applied force and the friction force. So our equation is the net force equals to mass times the acceleration. In this case, the net force in the horizontal direction is Fa minus the friction force equals to 0 because the acceleration is 0. So that means applied force equals to the friction force. So friction force must be 2 newtons. The second example, we have the same block. The applied force is not given. It's labeled as F, but the coefficient of friction, mu k, is given as 0.2. So now let's try to find out the friction force. In this case, we start with the free body diagram again. The normal force, weight, the applied force F, and the friction force. So in the y direction, Fn minus mg equals to 0. So Fn equals to mg. So that's 3 times 9.8. So 29.4 newtons. Now we know that friction force Fk is equal to mu k times Fn. So that's 0.2 times 29.4. So that's 5.88 newtons. Second example, a block slides down an inclined plane. Find the acceleration of the block. Mu k is equal to 0.1. Mass is 8 kilograms. So this is the free body diagram. We have normal force in the y direction and the weight is downward, and friction force is parallel to the x-axis but is in the opposite direction to the motion. So if we consider the y direction here, we have normal force, then we have a component from the weight which is mg cosine 40 and equals to 0 because there is no acceleration in the y direction. So that gives us the normal force. Fn equals to mg cosine 40. So that's 78.4 times cosine 40 equals to 60.1 newtons. So once we have the normal force, we can find the friction force, mu k times Fn. So 0.1 times 60.1. So approximately 6 newtons. Now we can consider the x direction to find the acceleration. In the x direction we have the friction force and then we have mg times sine 40. So mg sine 40 minus F equals max, or in fact you can write it as F minus mg sine 40 equals m times minus ax, basically multiplying this equation by -1. So 78.4 times sine 40 minus 6 equals to 8 times ax. So it's 44.4 equals to 8 times ax. So the acceleration is 5.55 meters per second squared. Example number 3, the static friction coefficient between the tires and the road is 0.25. When the car is traveling at 30 kilometers per hour, what is the minimum stopping distance of the car? To answer the question, we need to find the friction force, and then we need to find the acceleration of the car. So by looking at the forces, we have the normal force, weight, and the friction force. This is what makes the car stop. So this force is the force that stops the car. So we need to find this force in order to find the acceleration. Between the car and the road is the static friction force. In a rolling motion, it's always the static friction force that applies because there is no relative motion between the surface and the rolling object. So the static friction force is equal to mass times the acceleration, because that's the force that creates the deceleration, in fact. So that's static friction force then also equals to mu s times Fn, and that's equal to ma. But we know that normal force Fn is equal to mg because there is no acceleration in that direction. So if we plug mg here, we get mu s mg equals to ma, and we can cancel m. So the acceleration would be mu s times g. So that's 0.25 times g. Then we need to use kinematic equations to find the actual stopping distance. First, we need to convert 30 kilometers per hour into meters per second. So that becomes 8.33 meters per second. Then we can use the equation v squared equals to v0 squared plus 2ax. The final velocity v is 0. Initial velocity is 8.33. Acceleration is 0.25 g. So x becomes 8.33 squared divided by 2 times 0.25 times 9.8. So it becomes 14.2 meters. Example 4. Now is again an inclined plane. It says a block of mass m is sliding down a slope at a constant velocity. Find the coefficient of friction between the block and the slope. Now again, in this situation is a constant velocity, so the acceleration is 0. That means the acceleration in both x and y directions are 0. Now using the free body diagram, we have normal force in the y direction, friction force in the positive x direction, and mg pointed down. The angle is 40 here. Considering the x direction, we can say Fk minus mg sine 40 equals to 0 because the acceleration is 0. So Fk equals to mg sine 40. We also know that Fk is equal to a mu k Fn. So by using that, to use that, we need to find Fn first. Fn is mg cosine 40 because in the y direction again there is no acceleration, so this Fn is equal to the component of mg in the negative y direction, so Fn equals to mg cosine 40. So now we can plug this Fn into the previous equation, so Fk becomes mu k times mg cosine 40. Now we have two equations for Fk, so we can equate these two. By equating the two equations, we get mg sine 40 equals to mu k mg times cosine 40. We can cancel mg, then it becomes sine 40 equals mu k cosine 40. Mu k equals sine 40 over cosine 40, which is tan 40. So mu k equals to 0.84.